Now we will see the introduction to the mesh analysis that starts from planar circuits. Okay, so what is meant by planar circuit means the circuit which can be drawn on paper without crossing any branch. Okay, such type of circuit is a planar circuit. Okay, so for example, this is one circuit, some elements are there. So I have drawn this one on the paper without crossing any other branch. For example, another one I am taking. Same thing, but extra branch I am connecting like this. So to draw this extra branch, okay, whatever the extra branch I have taken here, it is coming out of the paper. So as per the definition, is it violating the definition? If you think like that, it is wrong, because I have drawn like this, but without coming out of the paper and without crossing any other branch, I can able to draw this. How? Okay, whatever the particular branch is there which is coming out of the paper, which can be drawn without coming out of the paper and without crossing any other branch like this. Or you can draw like this. So all the branches I have drawn on the paper without coming out of the paper and without crossing any other branch. So these two are equivalent only. Okay, these two are equivalent only. So all these are planar circuits only. Okay, now I will draw in a different manner. So here another set I am taking, and this is the thing. For example, this is node A, this is node B. Now I want to draw one more branch in between A and B. Is it possible to draw on the paper only without coming out of the paper and without crossing any other branch? Can I draw the branch from A to B? No. So it is now not a planar circuit. I have to come above the paper and I need to cross any other branch to draw the branch between AB nodes. Okay, so it is not a planar. So for such type of circuits, we cannot able to apply our mesh analysis. Okay, mesh analysis is suitable for planar circuits only. That's why it is required to study what is the planar circuit. So this is the definition of the planar circuit. Now coming to what is loop. In the circuit, if you start from one node and you go throughout the circuit or some branches of the circuit and come to the same node, then that is the loop. For example, you have started here, you have traveled like this and coming to the same point, then that is the loop. So mesh also same thing only, but there is a change. Okay, so for example, I'm taking, this is a circuit. So this is the loop and mesh also. This is the loop and mesh also. What about this one? It is just loop, not a mesh. Because mesh means a loop without any other loop inside it. That is the definition of the mesh. So if you take the mesh, within that particular mesh, no other mesh should be available or no other loop should be available. Okay. So once again, I'm drawing here. See carefully. For example, this is what I have taken. Now you identify what are the meshes. So this is the mesh. This is the mesh. This is also the mesh. So identification of the meshes is straightforward only. Okay. But it is not a mesh. Why? Within that particular loop, we are identifying some more meshes. Okay. It is not a mesh. Okay, because within that one, two more meshes are there. So that mesh, if you select the mesh within that one, you should not find any other mesh. Okay, so it is a straightforward thing only. So like that, you can able to identify the meshes. Okay, so after identification of the meshes, we need to assign the mesh currents. Okay, it is we can able to compare this one with the nodal analysis. In the nodal analysis, after identification of the principal nodes, you will assign the nodal voltages. In case of the mesh analysis, after identification of the meshes, you will assign the mesh currents. So in the nodal analysis, you are looking for the nodal voltages. Those are like variables V1, V2, V3, you have to take like that. Here mesh currents you have to identify, and you are looking for solving or getting the values of the mesh currents only, I1, I2, I3 like that. Okay. So that is the part we are going to see in the mesh analysis.